Hi, it's time for another math easy solution. Time to discuss further into modeling with differential equations and look at motion of a spring and go over example 1 of the example video series. And basically solve this example, which states part A, for what non-zero values of k does the, or just a constant k, does the function y equals sine k times t satisfy the differential equation y double prime plus 9y equals to 0. And then part B, for those values of k from part A, verify that every member of the family of functions y equals a times sine kt plus b cos kt is also a solution. So if we were to look at to see if this function is a solution to this differential equation, again, it's differential equation because it contains the function and its derivatives, and in this case the second derivative, so it's a second order differential equation. So for part A, to find it, what we got to do is just plug whatever values we know into this equation and see what values of k match up. So we know that y is equal to sine kt, or this is what we're trying to prove. So now the first derivative of this equals 2 sine, and this is cosine. The derivative of sine is cosine kt, and then using chain rule, the k is a constant, goes in front. And now the second derivative of this equals 2 cosine of t. The derivative of cosine is negative sine, so what we have is negative k sine kt, and then using chain rule, the k goes in front as well, and then there's be 2 k's, so k squared. So let's plug this inside our y double prime plus 9y equals to 0 differential equation. So what we end up having is negative k squared sine kt plus 9, so that's our y double prime, and then our y is sine kt plus 9 times sine kt equals to 0. So we can put a bracket like that. Now what I'll do is factor out the sine kt, and now what we'll end up having is, when we factor that out and then move this around, so this is, we'll have a negative k squared plus 9, or 9 minus k squared equals to 0. So I factored that out. So what we end up having is this is equal to 0 whenever this is equal to 0, or whenever this is equal to 0. So if this part equals to 0, we get our values for k. So in this case, to make it 0, the k's have to be equal to, so we'll have to have negative k squared equals to 0. 9 minus k squared equals to 0. So let me just write this one time neater. So solving for k, what you end up having is k squared, this 9, move the k on the other side, we'll have a k squared equal to 9, and then, or I'll just move this around. Yeah, let's move this around, so we have 9 equals to k squared, just move it on the other side, and then solve for this square root both sides. We have k is equal to plus or minus square root 9, which equals 2 plus or minus 3. Square root of 9, like that, and you have to do plus or minus because inside this k could be negative or positive, and then it always becomes positive when you square it. So that is our k values. Yeah, so thus that's our k values, and our functions are going to be equal to y is equal to sine of this is again plus or minus 3, so it's either 3t or sine, or y equals to sine negative 3t. So that is the solution to that differential equation. It's one of those two. So now if we look at part B, and it states for those same values, so again plus or minus 3, verify that every member of the family of the functions y equals a times sine kt plus b cos kt is also a solution. And again, we'll assume a and b are constants. So what we have here, y is equal to a sine kt plus b cosine kt. So again, the derivative of this, first one because we want to get to the second derivative to match the equation of the differential equation. we get here a sine, the derivative of sine is cosine. Cosine kt, put the k in front using chain rule. So, and then the second part here, we have, this is going to be negative sine, so again, this is going to be negative b sine kt, and then put the k outside in the front. And then the second derivative, same idea, we have again ka, derivative of cosine is negative sine kt, and then we have to plug in, I'm using chain rule, move the k in front, now we have two k's, multiply by each other, or just a power, like that. Let's do this a bit neater. And then minus, now the same thing here, this is kb, derivative of sine is cosine kt, and then chain rule, put the k in front, k squared. So now let's plug this into our differential equation, which is plus 9y equals to 0. Or y double prime plus 9y equals 0. So let's plug those in. So our y prime is negative k squared a sine kt minus, this is going to be k squared b cosine kt, and now what we have is plus 9 times y, which is y is here. Let's just multiply that inside. So plus 9a sine kt, and then plus 9b cosine kt, and this all equals to 0. So we have these two, stuff like that. So what I'm going to do is factor out the sine and the cosines. So what I'll do is just write this down here. So I'll factor out the sines. So the sine is going to be something like this. So sine kt, what we end up having is we have this a and k squared. Also there's an a right there, and so the sines have an a, cosines have a b. So instead I'll just factor out the a as well. So I'll factor this out. So we have a negative k squared and a 9 squared wherever we have the, and a 9 wherever we have the sine kt or the a sine kt. So what we end up having is this is going to be 9 minus k squared. And then we have here, and now we plus, and then we factor out the cosines, the b cosines from these two remaining terms, and now we have again a negative k squared and a 9. So this would be a 9 minus k squared equals to 0. We can factor this out all again. So we can factor out the 9 minus kt, k squared. So what we end up having is, factor that out, a sine kt, a sine kt plus b cosine kt equals 0. And again, notice this is just our y function. That's just our y. So we did not end up having to make it even more, just to go further, because it's pretty interesting. So this is going to be y equals to 0. So what we end up having is again, this right here has to equal to 0 to be a solution. And then what you end up having here is, if k is equal to plus or minus 3, what we end up having is 9 minus plus or minus 3 squared, which equals to, well, 9 plus or minus 3 squared is just, that is just 9. So this is going to be 9 minus 9 equals 0. So as you can see, this is a solution. So our function y, a sine kt plus b cosine kt is also a solution. I'll write this whole thing down. It's also a solution if k is equal to plus or minus 3. Yeah, so again, it's a solution for the differential equation that we have 4 y double prime plus 9y equals to 0. So yeah, that's pretty much it. Anyways, that's all for today. Hopefully you'll learn from this pretty interesting example on differential equations and how to go about solving them, and in this case proving that this trigonometric function is a solution to this second order differential equation. Again, second order because it has this double prime or the second derivative. Anyways, that's all for today. Hopefully you learned. Like always, you can download these exact notes in the link below. And thanks for watching, and stay tuned for another Math Easy solution.